Hello everyone, welcome you all to Technobase Polymer Tech Talk. This is a virtual event series by Technobase on polymer science and technology, which we organize on a regular basis. Probably this is the first webinar of this one in this 2020-26, and I'm hoping to have more topics like this in the near future as well. And today's episode is focusing on the XL-ETFE, power beneath the wings, the leading materials in the aerospace cable industry. I think this is a very important topic and also a niche market. And we have our guest speaker is a Dr. Wenyu Shang, is a Chief Technology Officer at the Xinjiang Qingmei Technology based in China. Is well experienced and highly knowledgeable, and we invite him to give a talk on this subject today. Before I ask him to make a presentation, let me quickly introduce to you all about the Technobase. There's a lot of activities we are doing in this 2026 and many more to do. Technobase it's recognized as the gateway to global knowledge and business growth platform for the polymer industries and the technologies. So this is actually, this Polymer Tech Talk is one of the activities. That's where you connect industry and the technology suppliers. It's knowledge sharing platform. Technobase is a 20 years old company, and we are specialized in the polymer industry. When you talk about polymer industry, you're talking about the rubber, plastics, polyurethane, and also we cover on the non-polymer side on energy, environment, water treatment as well. Main activities, as mentioned before, we focus on the education and business activities, business growth activities. So we have exhibitions, conferences, trainings, webinars, business consulting, networking events. We also educate we have diploma programs, we have a library. So a number of things are there. I do encourage you to check our website, technobase.org, for more information on it. Okay. Just give you some update on upcoming activities. We are organizing in Malaysia in at 30 to 31st March. One event is called Polymer Composite Week. It's our first time organizing. It has an exhibition and a forum on the latest technologies and composites, materials, technology and application. This is one of the growing area in the polymer industry, composite side. We do have a PU week, polyurethane week, which we are organizing during 30 March to 2nd April. That's also in Malaysia. As you can see, there are a number of events happening parallelly. One focused on the composites, other one focused on the PU. And we do have other one also introducing our medical polymer week that is also focusing on medical devices, materials, applications. So it has a conference program, there is a training program, and exhibition section is also there. Another area that we're doing is in Asia Functional Film Expo. At the same time, all in Malaysia. This is targeting Malaysia as a center for the Southeast Asian region. So we are targeting all the buyers and the industry fraternity to come here during 30 to 31st March. I encourage you to participate, either you exhibit or visit or listen to the presentations, whichever is relevant to you. We're also having a kind of scientific conference at the same time, academic and also industrial depolymerization summit, which we're organizing in Bangkok, 1st to 2nd December in 2026 at Bitech in Bangkok. So I think this is one area a lot is happening in the recycling, upcycling, recycling, and so the depolymerization is one of these conference that we are first time organizing in Bangkok. So these are activities. We do have a magazines also. I encourage you to read the magazine. This is a free subscription. You can read. We have cover stories with industry specialists and researchers. We have plastics review currently, PU review. We have and also a rubber review. So whichever depend on your area of interest. Free to subscribe. Go to our website publication.technobase.org. So that's it. That's briefly about what activities. And if you're using the WhatsApp, if you like to follow us, wanted to get update on our activities, you can scan our WhatsApp group, Polymer Professionals. It covers, we have various groups, but Polymer Professionals is one group that we have, where you have the technical people, researchers, students, industry also part of it. So please do scan if you like to part of our WhatsApp group. Other one is, you can also follow us on official if you're a user of the Instagram, which is also one way to connect with us. So please do follow us on Instagram. You can scan this QR code if you know how to use it. Already member of it, that's fine. And if you're not yet, I do encourage you to be following our official account of the Technobiz on Instagram as well. Okay, that's about it. So let's get to the today's episode of the Technobiz Polymer Tech Talk. And our invited guest speaker is Dr. Wenyu Shang, Chief Technology Officer at the Xinjiang Qingmei Technology. We will be speaking on XL-ETFE, power beneath the wings, the leading materials in the aerospace cable industry. So please join me to welcome Dr. Shang. And if you have any questions on this presentation, please post questions in the question box. At the end of the presentation, we will address, Dr. Shang will address these questions appropriately. So join me to welcome Dr. Shang to give a talk. Let me ask him to share the screen. Yeah.
Yeah, can you guys see my screen now?
Yes, I can see the presentation is all right, and you can put in the full screen mode.
All right.
And open your camera.
Okay. Is this okay now?
Good to go. Thank you.
All right. Thank you, Priyam, for the introduction. As Priyam just mentioned, I'm Wenyu Shang, and I'm the CTO of Trauma Technology, based in China, Xinjiang, China. So we are a specialized polymeric technology company in China, and we are focusing our business in developing specialty polymer solutions for various applications. So on this platform, currently introduced by Priyam, we have made a series of tech talk on this platform. This is the fourth of the talks. In the past, we have talked about plastic, steel, composite sheet for building and construction materials, and highly weatherability polymers for building and construction applications. And if you have interest in those business, you can go back and search for the historical talks we have made on this platform, and we can learn more from there as well. And the topic today is about cross-linkable ETFE resins for the high heat resistance communication cable used for aerospace cables application. So let's dig in the details of the presentation. So this is the content. We're going to introduce myself, introduce the company, the products, our specialties in these industries, and our marketing powers, especially in the international market powers in this industry, and let's go from there. Okay, so firstly about myself, my name is Wenyu Shang. So you can see the pictures, the picture of myself is over there. I am kind of a veteran in the polymer industry. Okay, so my core expertise focus on polymer technologies, formulation development, of the processing equipment related with polymer development and processing, and application development. So in the past 30 years, I have worked for multiple prominent polymeric companies like GE Plastic, Dow Chemical, so on and so forth. And I developed my academic professional skills, through my master and PhD programs in Xi'an Jiaotong University. It's one of the most prominent engineering universities in China. So, okay. And now, as we said, I am CTO of a company called Trauma Technology. You see the name on the left hand. Okay, so this company is founded in 2008. So we have operated in the industry for almost 20 years. And Trauma Technology is focusing our business in the polymeric material development and the application development of those specialty materials, polymeric materials. So up until now, we had accumulated experience and application expertise in multiple areas, including the ASA granular films for the highly wearable applications for building and construction applications, as we just mentioned, for the previous three series tech tops on the platform, and cross-linkable ETFE for aerospace high heat resistance cables applications, which is the topic today, and other ASA for polymer and other specialty polymers related with multiple areas of applications, for building construction, for aerospace, medical care, electronic and electrical and electronic industries. Okay, so these are a few pictures. We would like to give you a understanding of who we are, what equipment and capability we have. So you see the building, that's our headquarters in Xinjiang, Henan province in China, and that's also the production center resides in. You also see the lab on the right-hand side. You also see the clean room lab and production site on the lower left hand, and on the lower right hand, of the film production capability we have in our production center. Okay, so now we'll dig in the ETFE, cross-linkable ETFE products in the topic today. So why we have interest in this area? And because of it is exactly because of the fast growth and fast development of the aerospace industry. So not only in China, but largely across the whole world, we see a very fast growth in the market's demands related with aerospace, like airplanes, rockets, satellites, and other high-end material development related with these industries. So for any of these sub-segments, there are a large amount of demand related with polymer material used in each of the applications. So being a specialty polymeric material developer, we of course like to participate in that industry, and we have developed the two series of products we will be mentioning today to be used on the communication cables on all these devices. And the technical background related with the application is can be split in two. So you can see two kind of technical demands called for from the aerospace industry. On the left-hand side, we color that in orange, right? So about why we need such a specialty polymeric material used on the aerospace cable. So the first one is extreme high temperature resistance. That's because when we install the communication cable on an airplane or on a rocket, so the airplane or the rockets need to operate on the very high altitude versus the ground. So when the airplane flies high up above the ground, like 10,000 meters away from the ground, then the surrounding environment would demand the airplane to pass through a very cold environment. So the cable need to sustain a very low temperature when it's working on the airplane, while at the same time, the working parts like the engine, like the shutter, or like the wings, or like many of the sensors collecting data from the environment and feeding to the flying control unit of the airplane, the cable need to be worked in a very high temperature as well, especially when the cable goes nearby the engine or nearby the sensor, working in hot environment. So the typical high temperature gauge required for this type of cable can call for temperature up to 200 degrees C to 260 degrees C. So in this temperature range, very few polymer materials can sustain a long time working environment at such a level. So that's why we need to develop this XL-ETFE material to fulfill the application demand. So besides that, for the arc resistance, for the forced hydrolysis performance, for the dynamic cutting through resistance performance, also are the key requirement for these cables, because you can imagine for airplane to fly through the air, it's inevitably would encounter heavy wind, right? So, or the plane, need to go up, down, left, right, and when the airplane flies through the air and doing all this, and the parts need to be moved, need to move to the right direction or the right position to control the flying position of the airplane. So that introduced all this arc resistance, forced hydrolysis, and dynamic cutting through performance, resistance performance, from the cable, and that translates the requirement for the insulation material. Okay, so on the right-hand side, we separate the space devices, like the satellite, like the space station, like the rockets goes beyond the atmosphere and work on the outer space. The long-range rockets or missiles need to work on the outer part of the actual part of the atmosphere level. That requires some additional technology demand, especially for the atomic oxygen exposure, like the radiation resistance, and special resistance to chemicals. It's like the propulsion agents used in the rockets are the specialty requirement for the devices working in the outer space. So that also translates to the requirement to the cable insulation material. Okay. Now, if we understand, if we try to understand the development route of the communication cable used in all this environment, we can loosely classify all these cables in 4 generations. For the first generation of the cables, they are more or less like the usual cable we used in our, in our house, in the car, or in the normal working environment, because they only need to sustain a low temperature below 100 degrees C. So most normal polymer materials like PVC, PE, TPU can be used as the insulation material to fulfill this kind of requirement. So that's the first generation of the cable. When the airplane, like from 50 years ago, when they flew really slow. So and they don't require such a high temperature resistance from the cable, so we can use the first generation to fulfill the demand. And when the airplane get more and more modern and fly faster and faster, and many of the working environments related with the communication cable raise the temperature up to 150 or higher degrees C, then the temperature resistance start to demand the cable insulation material to sustain temperature up to 150. Okay, so by then we started to use materials like PTFE, FEP, and other fluorine type polymer as the insulation material to fulfill the application requirements. And then, in the past a few decades, and then the airplane get faster and faster and more modern, and then installation material temperature demand start to surpass 200 and even to raise to 260, 280 degrees C levels. So that called for the third generation like the XL-ETFE and fourth generation like the Polymer plus fluorine polymer composite sheet, composite film as the insulation layer to sustain such a high temperature working environment. So that's why the industry had this two generation of insulation material being developed, and that's why Chuangmei also participate in the industry, and we also developed the same material, okay, to fulfill the industry need. Okay, the first solution we mentioned at the start of the presentation is the cross-linkable ETFE. That's for the third generation. So as you can see, cross-linkable ETFE, XL-ETFE, and the working mechanism of this material is we take a specialized ETFE and we compound it into a specialty formulation, which contains ETFE as the base resin, plus the radiation cross-linking agent and other supporting agent in the formulation, and make the whole material radiation cross-linkable. Now, when it is extruded on the wire and form a cable, so when the customer take the material and co-extrude it onto the wire core, the copper wire core, and then they would put the cable in a E-beam, electronic beam radiation machine to cross-link the insulation layer and make the whole cable finalized as a cross-linked ETFE communication cable. So after all these procedures, and then the cable have a cross-linked ETFE as the insulation protective layer on the cable, and that can help the cable to sustain a long-term continuous service temperature at 200 degrees C. So that is the whole procedure works, and that is the global industrial standard being used for aerospace cable need to sustain 200 degrees C temperature resistance. Okay. Now, this is a more detailed introduction of our existing products at Chuangmei Technology. As I introduced, we had developed this material in the past decades or so, from roughly 10 years ago. We had started the work, or complete the work, and then we had a very mature material available in the market, for our customer, and we also have many successful cases, with our customers, both in China and out of China, use the material to make such, XL-ETFE aerospace cables. So as you can see on the second line, I also mentioned previously that this cable need to sustain very low temperature, below up to -60 degrees C, and a very high temperature up to 200 degrees C. So this is a very wide temperature range the cable need to work on the airplanes and on the missiles and on the many the rockets or satellites like application areas. And on the last line of this page, you can see MIL-W 22759 and GJB 773, and these two are the industrial standards being used in the United States and China. So we all know these two countries, US is no doubt the leading country in the aerospace industry, right? So China is much smaller compared to the US, but China is catching up very soon, and expanding the industry. And these two countries more or less represents the highest industrial technical demand for this kind of application. And these two standards are the standard called for in these two countries, and our material were being tested and confirmed that we can conform to both standards on the aerospace cables. Okay, this is the certification we had acquired in China. So as you can see, it's in Chinese. So we asked the third party, certification agent to test our cable material and cable with it, with all the technical requirements by the 22759 equivalent standard, in China, and we're ready to offer this kind of technical support to anyone who have the interest to test it with us, and also because it is equivalent to SAE AS 22759 or the military industrial standard from the USA. And then we're having a full confidence that anyone out of China want to test our material, we're ready to offer our material, to offer our technical support to help you to make the cable pass through all these equivalent technical tests and trials. Okay, so this is a typical customer performance testing report we had acquired in the past with our existing customers, one of the customers, and then what the data shows is that we want to pass the same information to the industry that our XL-ETFE material is capable to fulfill this highest technical requirements from either China, US, or other countries aerospace cable application demand. Okay. Now for the fourth generation, so the XL-ETFE is the third generation cable solution, right? So now we go into the fourth generation aerospace cable, communication cable demand. Is the first question you might ask is why we would still need the fourth generation. So the third generation is very good, right? So it can work up to 200 degrees C. But the most important, most important factor is very simple, because the airplane is getting even faster. The airplane is fly even higher. So they demand even higher temperature. So the third generation with XL-ETFE material can sustain 200 degrees C, right? So some of the communication cables on the plane demand even higher temperature to 260. So the whole 60 degrees C higher than the third generation. So this was why the industry have developed this polyimide composite wrapping tape solution. So it is a very smart design of this fourth generation solution, because when you imagine it, when we take ETFE and co-extruded the ETFE on the outer layer of the cable and cross-link it with electronic beam, and then there is a limit to it. Even when we shift from ETFE to an even higher, slightly higher temperature resistance fluorine polymer, we can increase the temperature resistance up to another 10-20 degrees C. But there is absolutely no way to increase such a technology to 250, 260, or even 280 degrees C resistance. So we had to develop a totally different polymeric insulation material to sustain such an extremely high temperature resistance. So this is why polyimide came into the picture and play as a core material for the fourth generation insulation material. So polyimide, as if we have learned any entry level of polymeric chemistry, And we all know polyimide is a thermoset resin, right? So the most prominent performance of polyimide is it can resist to very high temperature. So some of the polyimide resins can resist temperature up to over 300 degrees C. So in this application, we want the polyimide core film to sustain temperature up to 260. Okay, so now, as you can see from the picture on the left-hand side, it's a tape. So it's a very small, a very thin and narrow tape. So when we have this tape, we kind of wrap the tape with certain angle. Usually it's between 15 to 20 degrees of the angle. We wrap the tape onto the core of the cable with adjacent, two cycles of the wrapping, overlapping each other. Okay, so and then with each of the cycles, overlapping with the next cycles, and then we have an overlapping area, contacting each other, from the both sides of the PI tape. After we wrap the whole wire with this type of wrapping procedure, then we put the whole cable through a high temperature oven. Usually the temperature is set at 350 degrees C to 400 degrees C. Depends on the machine and depends on the speed of the wire passing through the oven, to solidify and to firing and solidify the whole wrapping layer into a continuous insulation layer. Okay, so because of we have this firing and solidification procedure, that's why we have this FP layer on the tape. So as I said, the core is the PI polyimide, right? So and then we put two FP layers on both sides of the PI film. FP stands for fluorine polymer, right? So we take a specialty fluorine polymer and we coat a very thin layer of the fluorine polymer on both sides of the polyimide film, and then we cut the film into a narrow tape. And then we wrap the tape onto a wire, as I just explained. So in the overlapping parts of the wrapping cycles, it is the upside fluorine polymer layer in contact with the bottom layer of the another side of the fluorine polymer coating of the PI tape, and then when we're passing through the cable through an oven, and these two fluorine polymers would be melt and form a continuous non-cracking continuous insulation layer over the wire. So this is, as I said, this is a very smart design, and this can include the benefits from both of PI, which is very high temperature resistant, and the fluorine polymer, which is very protective to the PI, to shield the PI away from the exposure of oxygen, water, and other chemicals, from degrading the PI layer. And while at the same time, these two layers of fluorine polymer coating on both sides are in contacting with each other, in the wrapping overlapping area, and then they would be melt and form a continuous insulation layer. So yeah, so through this design, we can produce a high temperature resistance aerospace communication cable with it, and make the wire to sustain very high temperature working environment. Okay, so just keep that wrapping and solidified insulation layer in mind, that we can call for the benefits from both PI and fluorine polymers, and then we can extend temperature working range from -60 to 200, and then to a new range. This new range expanded on both ends of the spectrum. So on the lower end, we can push even to a higher even lower temperature from -60 to -65. Okay, so it's an even colder working environment. On the high end side, we pushed up a whole 60 degrees C range. Okay, this is the most important difference and most important benefits we can call for from the fourth generation insulation material and fourth generation aerospace cables. Okay, now this is a basic structure we formed, with the PIFB racking tape. So I already explained a lot with the previous two slides, right? So, and here is a picture, and you can see the PI sit in the middle, and we coat a specially modified PTFE coating on both sides of the polyimide film. So, this PI would offer the very high temperature resistance as a core performance, and these two PTFE sandwiching structural layers would offer the protection to the PI film, and would melt and form a continuous insulation layer in the final cable production procedure. Okay, so so this is on the left-hand side. You can see some demonstration of all the cables being used on the airplane. So this picture was taken from a Airbus A380. So it is one of the largest, passenger airplane in service these days. And for every single A360 airplanes, there are over 1,500 kilometers cables being deployed in the airplane. This is one corner of it, so you can see how many of them being cranked into one single airplane. On the right hand side, this is the cable structure I just mentioned. Okay, so there are two pictures are kind of showing a similar concept. So for number one is a conductor, which carries the signal of the communication cables in the real application, and the number two, of the yellowing layer on the upper picture, or number three on the lower picture are the PI and the fluorine polymer layers. So this is the final structure, right? So I'm not sure if you guys can see the wrapping line in the picture, but if you see close enough, there is a very clear wrapping line in the area. So basically, it is installed on the wire. As I said, you wrap the tape with certain angle and with the adjacent two cycles overlapping each other on the cable. And then after the cable is being made, like this structure, the whole cable is put through a oven with temperature between 350 degrees C to 400 degrees C, to make the second layer a full continuous and non-cracking insulation layer to offer the high temperature resistance performance. Okay, so yeah, so we see some performance. Okay, as I said, in one of the previous slides, we explained the high technical performance demand from airplanes and from rockets and from satellites. And here are some actual numbers. Okay, so the benchmark is for the fourth generation, the PIFB tape is the best products or the industrial standard products being used worldwide. Here are the technical performance of their tape. And our tape performs like the CM tag, marked with CM tag on the right-hand side. So we are confident to provide a product with equivalent performance compared with the best benchmarking products in the world, and offer to our customers. And we're confidently can guarantee to our customer we can pass the most stringent industrial standard, as the 22759 or the 773B in China. The SAE standard is a standard used in the US and some countries in Europe, and is a de facto world industry standard. So that is the most stringent standard we can find in this industry. Okay, so here is a wrapping up discussion and comparison between the two generations. So we see the pyramid again, right? So from bottom to the up, that's the first, second, third, and fourth generation, and based on the temperature resistance, performance demand. And then we have our interest in the third and fourth generation of these communication cables. And then here are some performance demands between the two generations. So as you can see, the most important performance comparison is about the temperature rating. So the third generation calls for 200 degrees C, and fourth generation calls for at least 260. So there are some cables called for 280 degrees C, but it's a very small application area in the industry. So it's 200 versus 260, and we can make both material available at Tromei and offer to our customer, and help our customer to employ the material at their cable applications. Okay, so back to the application. As said, aviation, spacecraft, maritime, and railway, high-speed railway are all potential customers, and we see our cable being used in all of these areas. And if any of you have the interest to discuss the technology with us, and find out, if you have some specialty technology demands from your specialty applications, like you encounter some material need to sustain very high temperature, like what we explained here in the aerospace communication cable, just reach out to us. We can apply this technology together with you and find out the best solution for you. And if you already are in this industry, you are making the communication cables for the airplanes or for the space rockets, satellites alike applications, we are ready to work with you. So we have both of these solutions ready at Tromei Technology. We can offer samples, technical support, discussion, all these products and services to you. Anytime you want. Just reach out to us and let us know the application background, so we can offer the best solutions for you. Okay. So now we kind of conclude the product and technology introduction, which are two very specific products we like to introduce to you guys, and now we want to give a little broader explanation or introduction about our capabilities. So as we said at the beginning, Tromei Technology is a specialty polymeric material company, right? So our specialty focuses on specialty polymers. So we know in the past 20 years or so years, we had accumulated many specialty experience with specialty polymer development. Not only with ASA, not only with PC, ABS, or ETFE or this PI tape, and also in the course of the company history, we have developed many other applications as well with our customers. So this is the core of our expertise. We know polymer, we know how to develop the formulation, we know how to develop the application of the polymers in many different applications, industries, BNC, healthcare, aerospace, electronics, and so on and so forth. Automotive industry, so on and so forth. Okay, we also have accumulated lots of experience with the related equipment. About the equipment, how to make polymer materials, about the equipment, how to process materials, like the compounding machine, okay, twin screw extruders, single screw extruders, or the film production machine, sheet production machine, and other blow molding, injection molding machines. So we had a rich environment in those areas as well. So if you need any consultants, about the equipment, where to find the right equipment, how to set up your equipment, how to use the equipment to reach your goal, we are ready to provide the support and service to you as well. And in many of the cases, because we are a material company, so we sell material, we sell material related services. In many of the cases, we offer this kind of service for free. So we don't sell equipment, right? So we have the knowledge, but we don't sell equipment with ourselves. So we kind of offer this kind of service for free as part of our value add service to our customers in many cases. Okay, customization capability, we already mentioned this for multiple times. If you have a specialty demand, you have some difficulty in your application, you don't know how to deal with it, or you have some application, but you don't know what material is the best one for it, or you have the material but you don't know how to use it in the best way, we can customize the solution for you. So you can look into your case, pick the right polymers, and develop the right formulation and processing configuration windows, and we pick the right equipment for you, and we customize the whole solution for you based on your specialty application demand. Okay, integrity service, I won't repeat the points, but just for all those areas, equipment, material, application, if you have any questions, you have any demands, just reach out to us, and we'll talk with you and find the best solution for you. Okay, so we are based in China. But we are, present in, we have a rich business operation experience beyond China as well. So we have, customers in Middle East, Turkey, in North Africa, in Europe, in North America, South America, pretty much around the globe. We have many customers in many countries. And we love to work with you guys. Again, whatever application demand, whatever specialty applications, just reach out to us. We'll work with you on those. Okay, so market and partner. So yeah, I won't repeat reading the slides, but basically we are a specialty polymeric company based in China, but are willing to provide the service on the global level. Okay, so here are some specialty wire and cable customers we're serving in China, mostly in China, and these are specialty aerospace cable suppliers. In China, they are making wonderful cables, and that's being used on the airplanes, rockets, satellites, so on and so forth, not only in China but also in the international markets as well. Okay. Okay, so here are some repeating items. So we know polymer, we know the polymer related equipment, and we are willing and love to do business with you. So as long as we understand your what you need, just share with us. We'll work with you. Okay, so here are two key contacts. You can find us. So the first one on the left hand side is me. So you can see my mobile phone number, my email, and my WhatsApp QR code. And Jack Gao is our marketing director, so in charging of the international business. So his phone number, email, and WhatsApp QR code. Just reach out to us, so we're ready to talk with you anytime. So I think this is the last slide. I'll stop this page and I'll open to questions. I think back to you, Priyam.
Thank you, Dr. Shang. Thank you very much. Very interesting presentation on the cable materials. It looks like a very specialized product, right? Yeah. Okay, guys, you can ask the questions now. There are a couple of questions already here. Let me share this screen for you.
Mm-hmm.
Yeah. Okay, let me put it properly on there. Yeah. Can you see the slide? Yeah. Are you able to see the slide, Dr. Shang?
Yes. Which slide do you want to see?
No. I show this, question on the screen. Did you see my screen?
Okay. Sorry. So I just closed the screen. So the first question is how do nanocomposite fillers influence the dielectric properties and thermal conductivity of aerospace cable polymer? So it's a very expert and very good question. So nanocomposite, by itself is a very good material and very good technology that can be used in polymer solutions. But actually, in our solution, in both cases, for the either third generation or fourth generation, we actually didn't use any nanocomposite fillers in our solution. So for the XL-ETFE cases, the cross-linking agent is a liquid form chemical we use, and other supporting additives and agents, has the form in powder, but the powder is not nano-sized fillers we use. So yeah, in our case, we didn't use it. It's kind of irrelevant to our two products, for the topic today. But back to pure technical discussion, that nanocomposite fillers usually introduced very minimum impact on dielectric properties, because the filling level usually is much lower compared with normal fillers, on the micrometer level or even larger size level. So you need much small quantity of the filler, to introduce into the formulation when it is nano-sized fillers. So the dielectric impact is much smaller, and the thermal conductivity, with the same mechanism, is also much smaller compared with usual fillers. But in some special cases, like if you choose carbon nanotube or graphene fillers, on the nano-sized range, then the graphene or the carbon nanotube may introduce some significant impact on the thermal conductivity. So the graphene may significantly increase the thermal conductivity for the cable insulation or other dielectric application area. So yeah. Okay, I think this is the second question. What are the challenges and recent advancements in flame retardant polymer compounds for aerospace cable jacketing without adding excessive weight? So very good question again. The major challenge, for FR grade polymer for aerospace cable, is that, I would say summarized as in two aspects. First of the challenge is exactly as you said in your question. You don't want to add a lot of additional weight for the cable, because every ounce of the weight is precious for making a airplane or a rocket or satellites, right? So you don't want to use all those inorganic, a large amount of inorganic FR additive or filler into the compound to add the weight. So that is one challenge of the constraint. And the second is in the aerospace, the smoking density demand for the wiring cable is very stringent. You don't want any additional smoke being introduced into the airplane cabinet, when it's exposed to fire. So that two factors being combined together, ruled out lots of usual FR solutions. Like the large amount of inorganic fillers being used as FR agent usually is not applicable for the aerospace cables. You have to choose very good, inherent FR performance material as the insulation materials, like the fluorine polymers. That's PTFE, FEP, FEP and FPV. All these fluorine content polymers which are inherent FR, flaming retardant, to reach this balance. Of course, for the very high temperature resistance cables, in our case, mentioned today, is that you don't want to expand the size of the cable too much. So the communication cable usually are very thin cables being deployed in the airplane. You don't want to make the insulation layer too thick, which causes the whole cable has a much larger diameter, size with itself. So you want, back to the insulation polymer, you want the polymer being highly FR resistance and highly heat resistance, and while at the same time it can perform as a dielectric insulation material to make the signal carrying with high quality. Okay. The third question is, how do you decide a minimum insulation wall thickness when using XL-ETFE for high density harnesses? So this is a straightforward question that we mentioned the standard, industrial standard, right? So SAE 22759 or the Chinese standard GJB 773 B standard. This standard have very specific design range for the conductor size and for the outer diameter size of the cable. So when these two diameters being decided, the wall thickness is by default fall into a range. So there is a narrow range you need to have your insulation wall being made for certain cable. So there are around 30 different calibers for the cables. Each of the cable have a narrow range of the insulation wall thickness. Okay. What visual signs indicates aging or degradation of XL-ETFE insulation during aircraft inspection? Okay, this is a very good question. So there are several of the visual signs when you inspect the cable. The first one is micro crack. So especially, airplane is has a very tight inner space, right? So the cable, when the cable being deployed inside that space, it need to go through some bizarre ways to connect the sensor or the engine to the control center. So it inevitably need to pass some very sharp edge, and going very sharp angles, and then this cable at certain range need to go through a very small radius turning point. So this usually is the cable sustains the highest stress level, and in the long working time, are the reasons causing micro cracks in the insufficient material, and subsequently causing the failure, working failure of the communication cable. So when you inspect a long working time cable, the micro cracks or even some large cracks are one of the first aging signs you want to inspect of the cables. Number two is the color. So for the part of the cable need to sustain very high temperature. You can imagine for the whole cable connecting the control center to the engine or to the sensor, it's not the whole cable need to sustain 200 degrees C or 260 degrees C all the time. So it's only part of it are working under such high temperature. So this part of the cable over time will have its own color change because of the exposure to the heat. So if the color changed to certain beyond certain range, it's a very direct indicator that the cable is going to fail in certain time windows. So usually when the cable is being made initially, it's kind of the ivory white color with the XL-ETFE in the XL-ETFE cable case, or the pre-colored. We sometimes add the colorants into the cable, make it into red, blue, or green color. But regardless of the color of the cable being ivory white or red or blue, the part exposed to the high temperature, always need to go shift to a dark brown, to a light brown, heavy brown, dark brown color. So that is another key factor you want to observe, to the aging of the cable. In the case of the PI-FP tape, the outer space usually is a protective wrapping PTFE tape as well. So the same mechanism, mechanism also applies for the cable. You want to observe the change of color of that layer as well. So it's usually started as an ivory white, as you can see from the previous picture, that when it's getting aging over time, it's getting yellow, brown, heavy brown, dark brown. Okay. Next question, Priyan. Okay, so the question is, what processing controls are critical to ensure consistent XL-ETFE performance across long cable lengths? Okay, Because the ETFE, XL-ETFE resin is co-extruded onto the cable, right? So the most important processing control is how to control, how to make the XL-ETFE resin a steady flow through the extruder, through the mold, and being deployed surrounding the conductors. Okay, so to do this, to maintain a stable temperature and temperature control of the extruding machine, and to maintain a steady pushing force, which can be translated to the rotation speed, spinning speed of the screw, and the feeding speed of the resin are the most important factors. So as long as you make the temperature stable enough and makes the feeding rate and the extrusion speed stable enough, you will have a stable melt flow going through the mold and being applied around the core conductors stable enough, and then you will have a stable communication cable in the long run. Of course, the coaxial level is critical to the cable. So in the long run, in the unwinding side of the feeding unit and the winding unit at the end of the line need to be coordinated good enough that you have the conductor passing through the extrusion mode stable enough. So that is another key factor you may want to control. So in the real production, there always is one different spools of the feeding wire, right? So for the conductor, it's separate spools. When one spool is being finished and you need to continue to the second spool, so there's always a connecting point. So when the connecting point passing through the mold, passing through the machine, it's inevitably always introducing some turbulence, to the processing window, and that is also part of the processing. You want to pay additional attention to keep the short length before the ending point of the first spool, and after the starting point of the second spool, keeps the flow of the ETFE resin and running through of the conductor core were stable enough.
Dr. Shang, that's all the questions we have. I think
Thank you.
Thank you very much. Before I let you go, would you like to give a final message to the audience, please?
Okay, so today, thank you, Priyam. Thank you for everyone listening to us today. So today we have talked, two specific products, XL-ETFE and this PIFP tape. Both are specialty polymer products designed for aerospace communication cables. So we'd like to use these two products as a demonstration of the technology capability of Tromming technology, to show you what company we are and what capability we have and what kind of service we can provide to you guys. So again, as I mentioned in the presentation, if you have application related with aerospace communication cables, fine, excellent. Reach out to us. We have products ready to serve you. If you have any other applications or technical demands related with polymers, Tromming Technology is a specialty polymer company. So we have the capability, we have the service that can work with you and help you to resolve your issues or application demands. Okay, again, thank you, Priyam, for the opportunity, and again, it's a very good experience talking on this platform.
Thank you very much, Dr. Shang. It's a good presentation, and thank you all for joining this session today. I look forward to welcome you in the future episode of the Polymer Tech Talk. Thank you. Thank you very much. Bye-bye for now.
Yeah, thank you.